Good afternoon, everyone. My name is Mujib Rahman. I would like to give you an introduction and an overview about Flutter. So the first question is, what exactly is Flutter? To answer that question, let's look through the eyes of a developer. So here is Bob. So he is an iOS developer. He has made a really cool app which relates people to food, which became quite popular. So it's currently available only on the iOS. So the people who are using Android asking him question, posting on his website when it is coming to Android. So after giving so much thoughts, Bob finally find the time and he just bought a lot of books, studied Java, and finally he made an Android app. So the same app is available both on the Play Store as well as on the App Store. The people are really happy, but for Bob it's been very difficult. The problem is that if there is any updates that he has to do for the app, he has to do it 2 times. And for bug fixes, the same. He has to do it both for the iOS app as well as for the Android app. Also, he has to manage 2 code bases, which is really difficult. Also, he has seen some comments posted by his users saying that your app looks weird, like some icons looks really weird, some is twice the size of the other. So this problem arises because currently Bob has to take care of the display sizes from an iPhone to an iPad. Also, after release of the Android version, he has to take care of the Android part as well, because the Android devices, anybody can make it, and the number of devices are really huge, and each device has different display sizes, aspect ratio, and everything. So the guys at Flutter has this question: why can't we develop an app which really looks different on any screens? For example, the screens on the fridge, maybe the screens on the bus stop, and the screens on the mirrors. So the developer don't need to take care of any display related issues. Let the framework take care of that. So the developer who is planning to make an app, he just needs to take care of the business logic. So the Flutter actually is a UI toolkit which is used to develop beautiful interfaces. So the Flutter is basically built using widgets. So inside of Flutter, everything is a widget. So there is a widget called row, column, stack. So these are the widgets. For example, you just need to lay some stuff in a row wise, you just use a widget called row. And for column wise, you just use a widget called column. Also, there are some stuff that we just use from the web, like padding, margin, center, etc. So we just used to put the stuff in its right place. So how Flutter actually works is that it will ask for a blank screen, like a really blank screen, and it started painting one stuff online. Like if you need an app, if you need a place where you just need to put the title for your app, we just call a widget called an app bar, which started painting on top of a blank screen. And if you just need a button, it will start painting one top of the other. Also, there are some widgets, some pre-built widgets which can be used to develop stuff more easily. So instead of making an Android app in the Android way, in the iOS app in the iOS way, you just need to code it once and it will look beautiful on both the screens, for the Android and for the iOS. And for some stuff that is only related to one platform. For example, if you look at the alert dialog in the Android and the alert dialog in the iOS, it's different. It's totally different the way that it looks. So you can do that in the Flutter. For example, if the app is running on the iOS, you just can use the Cupertino alert dialog, or if it is running on the Android, you just can use this widget. So also there are some widgets like floating action button, linear progress indicator, so you just can understand from the word itself what are these widgets do. Floating action button is just a button which will be on the right bottom corner of the screen. So instead of building a button for your own, you just need to call this widget. So which is really easy. So Flutter works just like the way you're building a Lego block. So first you start with the basement and you just put one stuff on top of the other. So it's really easy building an app with Flutter. To give a code overview, you just can look at the code on the display. So just look at the line number 21. There is a highlighted text called app bar, and also look at the on the emulator on the top of the app. There is a red part which has a text called demo. So this is an app bar, so which displays the name of the application. Also in the line number 21 there is a highlighted screen called app bar. So this app bar is a widget. So instead of giving it size, giving it position, you just need to call the widget called the app bar. So it automatically put the part that you need to as an app bar on top of the screen. And also on the line number 25 there is a widget called center. So from the name itself we can understand that it used to put the stuff in the center, and in the center there is another widget called text. So it's just basic English. You just need to look at what the name of the widget, you easily understand what does it do. So this text has a string in between which is displayed on the emulator. Also at the line number 28 there is a widget called floating action button, which can be seen at the top right corner. So instead of giving its elevation, giving its position, you just don't need to specify everything. You just need to specify how does that you want to look. Like in the code in line number 29 you just give a color called red, and in line number 30 you just use a widget called icon which used to give this plus sign. So icons.add, which will give you the plus sign in the floating action button. So it's really easy to code an app using Flutter. The other advantages is that you can deploy it anywhere. So you just need to code it only once, and you can put the same app with the same code. You can take a build for the iOS, you can take a build for the desktop, you just can take a build for the web, also you can for the Android. So it's very easy if you build an app using Flutter. So that is, with one code base you can take build for an iOS app, a web app, a desktop app, also an Android app. So it's pretty convenient, we are cost efficient, also the time to build an app, which is relatively smaller, also the amount of resources, for example the number of developers to make an app for all these platforms are relatively lower if you are using Flutter. So in Flutter we use a language called Dart. So Dart is the language which is used to make a Flutter app. So Dart is developed by Google, and it is extensively used by Google's to make some applications like their internal application like Google AdWords. It is built using Dart. It is an object-oriented language which is similar to Java and C++. So if you know some Java, it's pretty easy to grasp with Dart. There is a feature called split-second reload in Flutter. So it's called hot reload. The technical term is called hot reload. So it is a feature where you made some changes to your app. You just change the title of your application to another, like you change the text. In order to reflect the text on your emulator which is running in parallel, you just need to hit save. You just need to save the code. The change will be exactly like within seconds it will be reflected on the emulator. So you don't need to restart the app or restart the emulator in order to see the changes. So it's pretty easy. Because of this, the development time will be relatively smaller. Also in Flutter you get access to original source code. So if you like to find how does a particular widget work, you can easily go to the source code and you can see how does that widget is coded. So it comes pretty handy where you have to develop your own widgets. You can use the original source code information. The next is the anatomy of a Flutter app. So in this part I will cover how does a basic Flutter app work, like how does it lays out, like what is the structure of a Flutter app. Maybe you can call it as an architecture, but not in a technical way. So inside a Flutter app we start with a blank screen. So on top of a blank screen we put a basement, which is the base layer for our app called scaffold. So it is like a foundation for our app where we discussed in the previous slide. We will build one app, one thing or one widget on top of the other until our app is finished. So our scaffold is the base or the foundation widget or the foundation layer for our app. On top of the scaffold we put an app bar, which is an app bar which displays the name of the app. So on the rest of the screen we put a widget called container. So container is used to classify an object on the screen where you have to group two objects which is lying next to each other. We use container, so which comes in pretty handy in order to classify the screen. Inside a container we plan to put two things on one top of the other, like as a column. So we use a widget called column. Inside a column, like the first part of the column, we put another widget called row. So we plan to put one thing right next to each other. So in order to do that we use a widget called row, and On the rest of the column, we put a widget called text. We just need to display an element in a text. So we are going much more deeper into the row, which we used another text on the first part of the row, and we used an icon on the second part of the row. So this is like, so you can see a tree is formed on the structure of our application. So our application can be visually seen as a tree, which can be seen in both, like the most popular IDE used for Flutter is Android Studio or Visual Studio Code. So inside the code editor, if you start running the application, you can visually see the structure of your current application in a tree structure. So this is called a widget tree. So where you can see the widget which is used in your application listed as nodes of a tree. So the code corresponding to the tree is shown on the right side. So you can see that the first part is a scaffold, which is this scaffold, and we have an app bar, which is this app bar, and the container. So yeah, now you got it right. So this is like the code is like a tree which is tilted onto the side. By the indentation you can classify which is the child of which widget, something like that. So the next is, let's look at some cons or the disadvantages of the Flutter app. So Flutter app, the size of the Flutter app is relatively bigger compared to another framework. So it has a lot of underlying codes and widgets. Even though the application is relatively simpler, you code maybe a Flutter app and the same app in a native platform, the size of the Flutter app will be higher than the native app. Also, compared to the performance or how responsive a Flutter app is, which is compared to the native app, which is a little bit performance lower than the native app, because there are some underlying code which happen the converting the Flutter app into its native language, so it takes some time. So it's relatively slow to a native app. Also, the community of the Flutter it is comparatively smaller than the other framework, because according to another frameworks like React Native or Ionic, Flutter is relatively new and the community is growing day by day. So the resources that you get online compared to React Native and Ionic, the Flutter will be smaller, but it is growing really rapidly, so you'll be okay. So that's all about Flutter. Thank you.
Hey guys, I am Beslin. So now let's dive deep into React Native. As we all know, React Native is one of the most popular cross-platform building tool available to us till now. It has been developed by Facebook, now known as Meta Platform Inclusive. It was released back in 2015, and now it is an open source project backed by Facebook ever since. It is a JavaScript based software solution and is built with React.js in mind. So it makes it a little bit easier for JavaScript developers to start with the project on React Native as quickly as possible. Here is also a link to the GitHub page of React Native, so you could also contribute and be part of the open source community if you wished so. So how does React Native work? We now learned that React Native is powered by JavaScript. So we may wonder, how does it actually power the application development process in React Native? Here, the JavaScript is used to create the interface of the application we work with. Since it is based on React.js, it also inherits the working mechanisms of React.js. For example, consider component-based development. If we look into the code to the right side, we can see it is a component-based React code at first. We are importing a button component from React Native module and using it as a reusable component here. But in order to create an application for different target platforms, it is harder, mainly due to the platform dependent APIs, which makes it even harder for cross-platform development compared to web application development. But React Native allows API access to that specific platform, which makes the application to communicate with the target OS just like a native application. So we got some idea about the React Native. So let's see how it really works under the hood. So in order to understand more about React and how it really works, we have to look into its architecture. React Native is single-threaded and everything is done asynchronously. So obviously when a component is rendered, others has to wait. As you can see in the diagram, there are 4 core sections in the React Native. So the React code that you write, which is very similar to React.js, the JavaScript that gets interrupted from what we write, and a series of elements collectively known as the bridge. And there is also the native side. The key aspect of the current architecture is that the two realms, JavaScript and the native side, does not really aware of each other. This means that to communicate, they rely on asynchronous JSON messages transmitted across the bridge. These are sent to the native code with the expectation that they will get a response in future. The React Native uses so-called threads in order to communicate within themselves. They are the main thread, shadow thread, and the JavaScript thread. The main thread is the thread which our native application runs on, and this thread can make changes to the UI in general in the application. The shadow thread is the background thread which executes everything from the JavaScript thread and calculates the layout and passes it through the app's interface. The JavaScript thread is an important player which is used for handling all the logic in our application, executing all of our JavaScript and React code mostly at the runtime. The current architecture that we discussed just now has some limitations, as we already seen. So let's see what they are. JavaScript and main thread do not directly communicate, but depend on the bridge. That means the bridge is the de facto communication channel between native and JavaScript world. Next, the limitation is a serializable bridge brings out unnecessary copying instead of sharing memory between the threads. Since it runs asynchronously, the data may or may not get to the other side. There is no guarantee that it will reach the other end. Larger data transfer could be too slow due to how the bridges operates. Then updating the UI asynchronously causes page jumps once the data is loaded after processing the request or waiting in line to execute. There could be flickering in the UI since all or maybe most of them are rendered asynchronously. Features from native modules cannot be entirely exploited since most of the time they need synchronous data access in the native side. There is a new proposed architecture for the React Native, and it may solve the limitations that we saw now. So the new architecture for React Native brings out some serious changes. The first big change is the bridge is entirely replaced by JavaScript interface, or JSI for short. The main purpose is to make the JavaScript and the native sides aware of each other and be able to communicate without the bridge. The next component is Fabric, which allows creating the shadow tree directly in C++ with the help of a UI manager, and thus improving the responsiveness in the whole application. Then there is a Turbo module, which is a native module but implemented and behaving a little bit differently this time. They are this time lazy loader, which means that the JavaScript code is going to load each module only when it is needed and hold a direct reference to it. Then we have code gen, which will automatically compatible with the JavaScript thread and the native thread that we have, and ensure they are always synchronized. And it is going to generate more native code at build time this time rather than the runtime. So now let's look into the advantages that React Native brings out to the table. Firstly, React Native uses JavaScript, which is one of the most commonly used programming language, thus easy to learn also. Secondly, code reusability and faster development. We could use the same code to target different platforms, and it supports code reloading, which makes it better to see previews at development stage itself. Then when it comes to performance, React Native gives a near native like experience, which comes handy for most of the applications. The other advantages of the React Native is the cost efficiency it offers. We don't need to have different development team for different platforms. Then there is also the advantages of a large development community that supports the React Native. That means we get more third-party modules and help from the community itself. On top of that, there is also an active support from Facebook as its open source initiative. So now let us see the drawbacks of React Native. First, even though it is released in 2015, compared to other native platform technologies they are using, it is relatively young. Secondly, React Native doesn't completely dismiss the native developers, which means there could be a chance for using native developers for certain scenarios, like to communicate with low-level APIs for a certain platform or for certain devices maybe. Other disadvantage some may argue is the too much reliance of Facebook in React Native. The biggest contributor to the development of React Native is Facebook itself, and sometimes it may be seen as a disadvantages for some of. And lastly, the performance. Talking about performance, near native performance is still not native level performance at the end of the day, and it may get worse when the app is dealing with lots of data or bridges. So since we covered the architecture overview of the React Native, let us quickly look into how the development with React Native is. So first, we need to have Xcode or Android Studio installed along with Node.js in order to start up with the project. We can also, in order to create a React Native application, we can either go with Expo CLI or with React Native CLI. The difference between two is that the React Native CLI supports native code along with JavaScript, and the Expo CLI only supports the API that comes with it, and no native modules can be added on to it later on. The images down shows how to quickly start your first React Native project in both CLIs. Now, talking about the development with React Native, it supports or works in similar way as React.js. So React Native components are structured like it. The React components here actually also contains the React Native components, which are from the community components, core components, and the native code that we write for a specific target platform. So talking about core components, we can look into the table. For example, in the Android, we use view group, and in iOS, we use UI view as a container for the layout of the application. And in the web, we mostly use div. But React Native provides a built-in component called view, which renders the layout using the native API for the target platform. This makes the development process much easier in cross-platform using React Native. So lastly, we could look the styling in React Native. The React Native, you can style your application using JavaScript or the core components that we saw, except a prop named style. The style names and values are usually matches how CSS works on the website, except here we have to use camel casing as shown in the example. We can also create a style sheet with style sheet.create to define several styles in one place, like in a CSS in a website. The code in the right side portrays this kind of usage. So that is all about React Native from my side, and my colleague will continue the presentation with the topic Ionic and Xamarin. Thank you.
The third platform which I'm going to talk about in this presentation is Ionic, and what are the pros and cons of building our cross-usage application using Ionic framework. So in Ionic framework is actually built by Google. So in simple word, Ionic framework is simple declarative UI components. So why is Ionic a framework and not a library? So the key difference between library and a framework is actually inversion of control. So when you call a method from the library, you are in control. But with the framework, the control is inverted. The framework calls you. Because Ionic calls your method, that's why Ionic is a framework and not a library. So why Ionic framework is best for hybrid application? So there are a lot of advantages when you go ahead with hybrid app development. It saves both time and cost of app development, so that with a single code base you can get app for distinct platforms like Android and iOS. And apart from that, Ionic framework is the most opted choice when it comes to hybrid mobile application, because Ionic framework is easy to adopt, hence developer get to make best out of its platform and its features. Other than that, the customizable component using Ionic for app development will give you an opportunity to work with the themes and the components that are highly customizable, hence you can build the app as you want. Also, you have the access to Cordova plugins with the Ionic. You get the best design with the hub of Cordova plugins. It allows you to access the best features like camera, flashlight, GPS, etc. Ionic is actually built with popular technologies like HTML, CSS, JavaScript, and AngularJS that enhance the performance of the developed apps. Hence, the less developed experience can develop excellent application. All it takes to build an app on the Ionic framework is some basic knowledge of apps and how they function on different platforms. Ionic has this sophisticated ecosystem. So Ionic shipped with its library of plugins, modules, add-ons of AngularJS, and add-ons of Cordova. Angular's plugin repository offers almost 2000 plus modules that facilitate app development and also the integration of web specific technologies. Services such as Twitter, options of UI elements, and system storage can be easily integrated with the app built on the Ionic framework. Like Cordova's repository offer a host of modules that support the development of technology driven apps. You can build application using Ionic that has the outstanding performance. Like the reason behind the Ionic framework popularity is that it focuses much on app performances. Also, the framework is designed in such a way to increase the app productivity. As a result, regardless of the device on which the app runs, it functions effectively and efficiently. You can test and modify locally using Ionic View so that you don't have to run the application every time on your mobile device like Android or iOS. You can just simply view it on your browser and just find out the bugs and errors, which is the possibility of crashing your application. Ionic is open source and free, so Ionic is completely free and open source platform available in GitHub. This is the best advantage to the Ionic mobile app development service fraternity. While using an open source platform, one of the drawbacks that developer face is instability of the platform. However, despite being an open source, Ionic is a highly stable and widely used platform. Ionic apps can be customized to exquisite performance on different mobile operating systems while being cost effective. Ionic is actually a performance based framework. So the apps built on because of the fact that Ionic is built on top of AngularJS, which provides several useful functionalities for developing hybrid applications. It provides a structure for making the programming more manageable by extending the HTML syntax. Also, it supports the two-way data binding, due to which every change in the UI immediately reflects in the underlying data model. A single code base across different platforms, Ionic allows the building of high-end user interfaces while using the same code to build application for different platforms. The programming languages that Ionic framework uses are easily converted from one operating system to another, which allow the apps to be used across different platforms. If one was to go for a native language instead of a hybrid, more effort and money will be required to learn languages for every platforms. Huge community to help. Like if one start the app development process with a new framework, even the expert developer face challenges. However, Ionic has the advantage of huge community support. Ionic framework is built with well-known technologies like Angular and Cordova and has the support of a strong active community. There are forums and blog posts already available for the Ionic app developers and members of the community to assist them when needed. You can build the Ionic application with the tech you prefer. So Ionic is engineered to integrate seamlessly with all the best front-end frameworks, including Angular, React, and Vue. Or even if you prefer no framework, you can use simple vanilla JavaScript to build your application on top of Ionic. Ionic has this great native access to native functionality of the mobile devices. You can choose from a rich library of over 120 native device plugins for accessing cameras, geolocation, Bluetooth, and more, or dive into the full native SDK when you need it. So there's no limit to what you can build. Okay, but everything has a trade-off. So what are the cons of Ionic? There are few disadvantages of using Ionic, like native plugins are not stable and can conflict with each other, but necessary to solve lack of features available in Ionic by default. So debugging of an application built on Ionic can be challenging and require more time because of unclear error messages, and the build can also randomly crash without any reason. It is impossible to ignore Xamarin when talking about the cross hybrid application development. So Xamarin is a Microsoft owned product. About 1 million developer uses Xamarin products in more than 120 countries around the world. Xamarin is a cross-platform development tool. It solves dilemmas many developer faces when developing cross-platform apps, separate coding languages, and UI paradigms. With Xamarin, you can use C# for iOS, Android, and universal Windows apps. Xamarin uses unique approach, native user interfaces, native performances, shared code across platforms, C# and .NET framework. Xamarin uses a single language C# to create apps for all mobile platforms, unlike other applications which uses different language to build different platforms. So Xamarin is a natively compiled, which makes it go-to options for building high performance apps with native look and feel. But there are cons of Xamarin as well. While the Xamarin library is extensive, more complex, project may require additional native coding. Xamarin apps contain a package that includes the app itself as well as the libraries, so apps are usually much larger than those that are native built, leading to slower downloads and install times. Developer must wait for Xamarin to integrate OS updates before they can update an app. These updates are sometimes delayed. I think that's it from our presentation group, and we will open to answer your any questions.
Hi, my name is Shazim Asher, and today I'm going to represent you the live demo of the Flutter application. And the name of this application is Employees App. What are the features of this application? This application will show you the list of employees, and you can add the new record of the employee data in this application. Then you can delete the employee data, and also you can see the employee's detail. What are the other things you will see in this application? You will see the form validation, toast messages, and other thing you will see the store data of the employee in the Firebase Firestore. Now I'm going to show you the live demo of this application on Android emulator and a physical Android device. All right. Now you can see that our application is running on the Android emulator. Now I'm going to run this application on the real Android device. For screen sharing, I'm using the voice application. Okay, I'm going to click on the app. Now you can see the list of employees already inserted in this application. Okay, for instance, if I want to see the detail of any of employee, for example, if I want to see the detail of Muhammad Adnan, I will just click on Muhammad Adnan. Okay, now you can see there is a detail of Muhammad Adnan's first name, last name, email, and date of birth. Okay, now I will show you how to add the new record in this application. For doing that, you just have to click on this plus icon button. Okay, now you can see you have to add some detail like first name, last name, email address, and date of birth. Before adding the detail, I will just show you how our application validate some incorrect fields. For example, if I click on the save information without entering any of information in above fields, let's see what happens. Now you can see that our application show you an error message like you have to enter the full name, last name, and the related detail. Okay, now I'm going to add some detail. Sada Hussain, and for the email I'm just entering the wrong email. For instance, Sada, I just write Sada, and the date of birth I'm choosing a random date. Now if I click on the save information again, now see what happens. So you can see there is another check. You must have to enter a valid email address. So now I'm going to add the real email address. Now if I click on the save information button, the record will be entered in the database, and I'm also showing you the record in the database. Now you can see this is a Firebase console, a cloud service which provides us the backend services for authentication, Firestore database, real-time database, also storage, hosting functions, and some other functions. So in this application, I'm just using the Firestore database for deleting and adding the user data. Now I will show you the latest record that I inserted. Yeah, this is Sada Hussain. Now I will show you how to delete a record and how it will be disappeared from here. For deleting deleting a record in this application, I create the functionality. You just have to double tap of any of the card. The record will be deleted from the application as well as from the database. For instance, if I delete the new record I inserted, for instance, Sada Hussain, then you can see our data has been updated as well as from database. For instance, if I delete the all employees data by double clicking on it, then you can see our application have no record of any of employee. So that's all from live recording of the application. Now I'm going to show you the code of this application. All right, so this is the code of our application. On the left side, you can see this is the project structure. This is the Android, build, iOS, lib. These are the directories. But today I'm just focusing on the Android and the lib. Okay, so this is our main dot file from where our Flutter project run. This function run our application. These two lines just to initialize the Firebase in our application. These two lines just to initialize the Flutter Firebase in your project. But before doing this, you have to add some dependencies here. And I'm just using the Firebase core and the Cloud Firestore. And Firebase core is used to connect your Flutter application with the Firebase. And this dependency is used to use the functionality of CRUD operations in the Firebase, and the Firestore is a NoSQL database provided by the Firebase. Okay, so how can we add the Firebase in our project? For doing that, you have to go to the Firebase console. So here you click the add project, and here you just have to add the name, like for instance, my project. Okay, so I'll create project here. Okay, so our project is ready. So for adding Firebase in your Flutter application, you can add this for iOS and Android, but for today's tutorial, I'm just doing for this Android. So you just have to click on the Android and do some more steps. To register your Flutter application, you just have to enter the Android package name. For this thing, you have to go to your Android project, and under the application build.gradle file, you will see the default config, and here you can find the application ID, and you just have to copy this file, enter here, and these are the option information. If you want to enter, it's okay, otherwise you can go. Register the app. This will generate a Google services.json file. You have to download this file, and you have to put this file in the app under the app directory here. So the remaining two steps are going next, and you just have to add this line in the project build.gradle file. So this is the Android, and in the Android you can see the build.gradle file. So here you can add this line as I already entered, so you don't have to add. Okay, and the last step but not least, you have to add this plugin in the build.gradle file, but this time you have to go to the app directory. So I add that plugin here. Yeah. So now our Firebase has been initialized for our Android application for the Flutter. Okay. Okay. Again in the lib folder, I'm here in the main dot file. So when this function runs, this run this method, and in this method, the build function calls, and it will create a widget, and this widget is the material app, and on this widget there is another widget which is showing in the screen, the employees, and this widget is displaying the list of employees here, and this whole screen has three parts: the app bar, and the list of employees, and the floating action button. So here is the code of app bar, and this is a body in which I can see the list of employees, and the last one is the floating action button to go to the new screen for the new employee. Okay, so for getting the employees, I created another widget, employees list. Okay, yeah, employees list. So this widget is building these cards, but there is a separate file for this card, employee tile. So here, and in the employee tile, in the build method, I use the gesture detector. And why I use this: for one time clicking on this card, you just this function will hit and will go to the next screen with the employee's detail. And when you double click, so this will delete the employee's record. Oh, sorry. Okay, perfect. So this was the employees list part. Okay, now for the new employee screen, when we use the navigator.push method to go to the new screen, whenever you click on this button, you will go to new screen with the new employee dot file. And for instance, if we click on plus, so you can see this file here. And again, this widget has the app bar and this form and the button. So here is a code for the app bar, as well as, and in the body there's a code for the form, and here is a key for the form, and it is a global key, the form state, which holds the state of your form. For instance, if you click on the save button, so this form key will validate all the fields, then you will go to the further step. So another thing, in all fields I use a validator, and I also created a separate file with the validator where you can uh, see all the code, how these errors are displaying on the screen. Okay, perfect. So for saving the record, when you click on the save information button, the data will be uploaded on the Firebase Firestore. So this is a separate method which first validate if your form current state is true, then all the data will be uploaded on the Firestore. So now comes into the Firebase service dot. So in this class, I created all the uh, functions for adding, deleting, and getting the employees list. That's all from my side. Thank you so much for listening, guys. I hope you enjoyed this video. If you have any question, you can ask from us.